Today we're writing equations in slope-intercept form. So the first thing we're going to do is review slope-intercept form. When an equation is said to be in slope-intercept form, it's in this format, y equals mx plus b, where m stands for the slope of your line and b stands for the y-intercept, or where the line crosses the y-axis. So when we're writing an equation in slope-intercept form, we have to consider what information is being given to us. So in these problems, they're giving us the slope and the y-intercept. So all I need to do is substitute my slope in place of the m and my y-intercept in place of the b. And then if there's any simplifying to be done to my equation, I want to do that. So in this case, for m, I'm putting in -3, my slope, and for b, I'm putting in 1/2, my y-intercept. So I have y equals -3x plus 1/2. In this case, that's our final answer. There's no simplifying to be done. Let's try another one. So in place of my m, I'm putting in 0. 0 is my slope. And in place of b, I'm putting in -2, my y-intercept. Now in this case, 0 times x is just going to give us 0. And 0 plus -2 is just going to give us y equals -2. So this time, my equation is y equals -2. Now sometimes we're going to be given a graph. When we have a graph, we're going to have to figure out the slope and the y-intercept from looking at our graph. So I've already done this one. Let's take a look at this one together. So my slope is my rise over run. So in this case, to get from this point to this one, I'm rising up 6 and I'm doing a run of 4. So it's up 6 and to the right 4 to get to that next point. So my slope is 6 over 4. The y-intercept, or where the line crosses the y-axis, is right here at -3. So in place of the b, I'm putting in -3. Now there's some simplifying that I can do here. 6/4 can be reduced to 3/2. And plus -3 can become -3. So for my final equation, I have y equals 3/2 x minus 3. I could also write it as a decimal and have y equals 1.5x minus 3. So let's try this one together. So I need to find my slope first. So in this case, to get from this point to this point, I'm going down 3 and over 4. So down 3 over 4. And this line is intersecting the y-axis at +2. So this is basically my equation. If I would like to write my negative out in front of the fraction, I can do so. But it's -3/4 x plus 2. Now sometimes we're just going to be given 2 points. And from these 2 points, I can find my slope. And one of these points that's being given to me actually represents the y-intercept. So since all y-intercepts are on the y-axis and all points along the y-axis start with 0, I know that this one right here is my y-intercept. So to find the slope, I'm taking my y values from my 2 points and subtracting them. So -1 minus 5. That's going to give me my rise. So I can change that to -1 plus -5. So my rise is -6. It's actually going down 6. And then I'm going to do the same thing for my run. 0 minus -3 is the same as 0 plus 3, or 3. So my run is 3. And -6 over 3 will reduce to -2. So -2 is my slope. So y equals -2x. And then it would be plus -1 or -1 for my y-intercept. So let's try this one together. So first, I know that this one is going to be my y-intercept. Y-intercepts always start with a value of 0. So now I need to find my slope. So I'm going to take my y's and subtract them. -5 minus -5 gives me -5 plus 5, or 0. And I'm going to do the same thing for my x values. 8 minus 0 is 8. So I have 0 over 8 or 0 for my slope. So I have y equals 0x, and here's my y-intercept, minus 5, or y equals negative 5. So this time I'm being given 2 points, but they're in function form right now. So this point represents an input of 0 and an output of 10, or I can rewrite this point as 0, 10. This is also going to be my y-intercept because it starts with a value of 0, so I know it's on the y-axis, and it will intersect at 10. My other point here has an input of 6 and an output of 34, so 6, 34. So the first thing I'm going to do is find my slope by subtracting my y values. 34 minus 10 will give me a total of 24. I'm going to do the same thing for my x values. 6 minus 0 is going to give me 6, and this reduces to 4. So my slope is 4. So y equals 4x plus my y-intercept was 10. So here is my equation. So let's try to write a linear model. So here's a new vocabulary word for us. A linear model is a linear function that models a real life situation. So it's an equation that we're going to write. It's a linear equation that represents this situation here. So excluding hydropower, the U.S. power plants have used renewable energy resources to generate 105 million megawatt hours of electricity in 2007. But by 2012, they were able to increase that to 219 million megawatts hours of energy. They want a linear model that represents the number of megawatt hours generated by non-hydropower renewable energy sources as a function of the number of years since 2007. So 2007 is going to be like year 0. It's going to start at 2007. And we're going to use the model to predict the number of megawatt hours that will be generated in 2017. All right, so the first thing that we have to do, we have to figure out a slope here for this data. So in 2007, that is going to be year 0. They created 105 million megawatt hours of energy. And in 2012, which will be year 5, because it's 5 years after 2007, they generated 219 million megawatt hours. So we're going to find the slope of this. This one's going to be our y-intercept because it starts with 0. So I have to do my y's subtracted over my x values subtracted. So 219 minus 105, I'm going to get 114. And 5 minus 0 is going to give me 5. And I'm actually going to reduce this one to a decimal here. 114 divided by 5 is going to give me 22.8. So my slope is going to be 22.8. So I have y equals 22.8x plus 105. So here is my linear model because this equation represents a real life situation. Now we're going to use that to predict in 2017 how many millions of megawatt hours of energy they're going to generate. Well, 2017 is 10 years after 2007. And remember, 2007 was year 0. So I have to plug 10 in for my input. So y equals 22.8 times 10 plus 105. So that's going to give me 228 plus 105, which is going to give me 333 million hours of million megawatt hours of energy generated by non-hydropower renewable energy resources.